Congratulations on hitting the end of this chapter. This chapter was all about objects and how they work with the const keyword. We started out by saying that if you declare your object as const, you're going to be automatically locked out of your object because you want to be able to read from the object. And we have seen this in the context of row variables and parameters that you pass to functions. And we have seen that the solution to that was marking your member functions as const and really make it clear to the compiler that they will never modify the member variables of your class. If you mark your member functions as const, then they will be callable even from const objects. We moved on and looked at how we could set up getters that could double as setters. So we could set up a pair of functions like this that work as getters and setters at the same time. And the trick is really to return a reference to the member variables. Then we can go through that reference to modify the object if we happen to need that. And we have seen that this was pretty cool. We also have seen that we had to go through const overloading to be able to use this kind of setup even for const objects. We then looked at some of the problems you might have if you try to use dangling pointers and dangling references in your C++ code. This would lead to crashing your program, and you really need to be careful and avoid these dangling pointers and references in your C++ code. We then explored the concept of const correctness, and we saw that the compiler is going to go out of its way to protect the constness of your objects. For example, if you're trying to call a non-const member function on a const object, you're going to get a compiler error regardless of whether the member function actually modifies or doesn't modify the object. If you want to call a member function on a const object, that member function has to be const. And we have seen many details about how the compiler does this. We then moved on and looked at how we could violate const correctness. We saw that we could mark some of our member variables as immutable, and this would allow us to modify our member variables even from const member functions. This is possible, and we have seen that it works. But again, I don't recommend this. This is going to make your code confusing, and it is reserved for really rare cases. I have said this, but I am going to say it again. I have been a C++ developer for almost 10 years now, but I have never used this. So don't use this feature unless you really need to. We then close the chapter by looking at structured bindings. This is a nicer syntax we have to access public member variables from a class, and we can do this and have nice A and B variables we can use to manipulate the values we have in our class object here. Please note that what we have in our structured bindings variables are going to be copies. So for example, if we modify the object here, the changes are not going to be picked up by our A and B variables. So you really need to know this. Another thing we saw is that it was possible to capture structured bindings in a Lambda function. And this is something that was added in C++ 20. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to try and explore more details about how constructors work. Go ahead and finish up here and meet me there.